We are given the graph of two equations in part A. Equation capital A is 2x plus y equals 2, and it's graphed as a straight line. Equation capital B is 2x plus y equals 8, and it is graphed as a straight line. For part B, we're given equation 2x plus 5y equals 1. That's equation A, and it's graphed as a straight line. And then if we carefully graph the second equation B, 6x plus 15y equals 3, it looks exactly like equation A. It's a straight line. It's exactly the same picture. Now we're asked to find the graph to learn if the system is consistent or inconsistent. If it is consistent, find out if it is independent or dependent. Okay, let's solve this problem. Part A, two lines in the graph that we see here for part A. Those two lines are, well, they're not perpendicular. They don't meet a 90-degree angle. They are parallel to one another. They never cross each other. They're parallel. That implies that there's no intersection of these two lines. They never cross each other. And if there's no intersection, that implies there's no system to this. There's no system solution. Remember, in order to be a system solution, a solution to the system, you have to be an ordered pair that satisfy both of the equations. To be an ordered pair that satisfies both equations, that means you're an ordered pair that lives on both equations. And if you live simultaneously, an ordered pair that lives simultaneously on both equations is a point of intersection where the two equations touch each other. Okay, well, these never touch each other, so there's no solution to the system. Thus, this system is called inconsistent. All right? They never cross each other. It's an inconsistent system because there are no points of intersection. There are no solutions to the system. The solution to the system would be empty. So we write the empty set symbol. It's a 0 with a line through it. It means the set is empty. The set of solutions is empty. Okay, let's look at part B. Let's look at the graph for part B. It turns out that the graph of line A is precisely the same graph as line B. So how many ordered pairs would these guys have in common? In other words, how many points of intersection? Every ordered pair they have in common. They cross each other everywhere. So that implies that there are infinitely many intersections of these two lines in the graph. Infinitely many intersections. And of course, that implies that there are infinitely many system solutions, in other ordered pairs. In other words, ordered pairs that they have in common. There's infinitely many solutions to the system. Thus, we say this system is consistent. Remember, if you have any solutions, one or infinitely many, it's a consistent system. Now, is it dependent or is it independent? This system is dependent because it has infinitely many solutions. If it had a finite number of solutions, and you could actually count how many there were, or there was a reasonable amount, not infinitely many, that would be an independent system. But this one is a dependent, consistent and dependent.